Trigonometry. Ready? This is a triangle, no? It looks like a triangle. Look like a triangle. Now the triangle has some things that are called points. I'm going to label my points. At each point, there is an angle. Now this is the angle A, angle B, angle C. Now each angle form a line. This angle form this line. And so this is line B. See that? If I use a different angle, it would have formed a different line. You see it? So this angle form this line. And this angle, so that means that the opposite of the angle is the line. You see that? Good. Take that out of the mind now. This is a triangle that they call a right angle triangle. That means that one of the angles is exactly 90. Can more than one angle be 90 degrees? Why not? Because the total for a triangle is 180. So if two have 90, then one have 0. You can't have that. So watch I know. The angle 90 is the biggest angle in a right angle. Because the other two must share 90. Are you understanding? And so this line, the hypotenuse, is the longest line and the one opposite to the 90-degree angle. Everybody see that? Hypotenuse square equal to opposite square plus ADJ square. What that mean? Squared. Huh? Suppose this line is equal to 3. And this line is equal to 5. And let me say find the length of this line. What is the length of this line? It's x. Now which line is this? The hypotenuse. So x squared equal to 5 squared plus x squared equal to 25 squared. No, it was 25 by 10. Square root 34. You see, if this is 5.8, you realize that this is still the longest line? If this is not bigger than them two, you have something wrong. Yes. Very easy. Huh? The what? If this is 8, what is the hypotenuse?
8.
So if this is 8, it suggests that 8 square equal to 3 square plus x square. 64 equal 9 plus x square. X square equals 64 minus 9. X square equal to 55. X equals square root 55. X equal what that?
7.4.
See that? All right. Ready. Let's go. Ready. Now, this here is the hypotenuse. The opposite is dependent on the angle for which we are referring to. If we are referring to this angle, then the opposite is here. And by extension, the other one is the adjacent. If you are referring to this angle, then the opposite is here. And by extension, the other one is the adjacent. So the opposite is dependent on the angle for which we are referring to. So therefore, if this is the angle, then the one opposite to the angle is called the opposite. And then this is the adjacent. And if this is the angle, the one opposite to the angle is called the opposite. And then this is the adjacent. Everybody understand? You understand? So therefore, the only one that is always constant is your hypotenuse, which is your longest line made from your biggest angle opposite to your 90 degrees. So if I draw a triangle looking like that, where is the hypotenuse? If this is my angle, where is my opposite? Watch your bottom. Here? And therefore, this is my adjacent. If this is my angle, where's my opposite? And where's my adjacent? Good. So now, they find that you have sine, tan, cosine, and tan. Sine angle is equal to your opposite over your hypotenuse. Cosine is equal to your adjacent over your hypotenuse. And tan is equal to your opposite over adjacent. So we'll give you an example. And tan. Sine, cosine, and tan. Me not tell you. Nobody beg me no light to of you. Oh, no light. So we want to find AB. So we're going to come now. Hypotenuse equal, which one is hypotenuse? Opposite to the 90 degree. This is the 90 degree, this is the hypotenuse. So A hypotenuse equal BC equal 8 millimeter. Which one is your opposite? Opposite equal AB equal X. How do I know that is AB more and find? They say find AB. You see that? So therefore, I have my hypotenuse and my opposite. What I'm going to use? Sine. Because sine angle equal to opposite over hypotenuse. So, since sine angle, that's why you write angle, equal OPP over HYP, it implies sin 22 equal to x over 8. What's sin 22 equal? 0. Alright, no, always, I want to know always put one and try find over this side. X over 8 equals sin 22. X over 8 equal what? 0.3 what? Where you get from the calculator? What? 0.375. X equal 8 times 0.375. X equal how much? X equal what? 2.99? 3. You see that? Everybody see that? All right now. Padadan. Where is the hypotenuse? $23.6. Where is my adjacent? AC more than 5. So it equals X. Where is my adjacent? Where is my opposite? Opposite of CB. See that? These are the angle. These are the opposite. Opposite. See there? Oh, it's wrong. What? At 60, this is done. You need to look properly. You need to wash out your eye. Huh? 20, or if it be 236 in one triangle. But it cannot be 236, only 180 can hold like a whole triangle. So, oh, one of them are going to be 236. I said 23.6. All right, ready now. So what we have? We have the opposite and we have the hypotenuse. So what we are going to use? Since sin angle equals opposite over hypotenuse, it implies sin 23.6 equals to 60 over x. Everybody see that? Because the hypotenuse is x. This implies 60 over x equals sin 3.6. Sixty over x equals sin 3.6. 0.4. That means that 60 equals 0.4x. See that? Because the x there below, carry it up above. 0.4x equals 60. X equals 60 divided by 0.4. X equal ANS 150 millimeters. See that? So it's simple. All right now. Find xy. This is a vector moving from x to y. The angle is a point called angle y. So if you want to find angle y, that's different from xy, which means from point x to point y, which therefore is the line xy. Hypotenuse. Which one is the hypotenuse? Which line is the hypotenuse? Opposite to the 90 degree. So that hypotenuse is 120. Sorry. Is XZ 120. What do we want? So therefore, what? Which is the opposite? YZ. But we want XY, which is the adjacent. All right. We want to do it different. Which one is the hypotenuse? XZ. So I want to say XZ equal hypotenuse equal 120. Which one they ask you to find? So xy equal, what is xy here? The adjacent, because this is the opposite. See why I'm telling you to do it so instead of putting the hypotenuse equal xz, put the first one, so you know what I'm fine. Equal ADJ equal x. Sine equal opposite over hypotenuse. Do we have the opposite? Cos equal adjacent over hypotenuse. Do we have those? Good. So we say that since cos angle equal ADJ over HYP, it implies that cos 38 equals to x over 120 equal cos 38 x over 120 equals 0.79, x equals 0.79 times 120, x equal what? What? 94.8, ANS round over. See that? Yeah, millimeter. 9 millimeter. All right, ready? This is, what do we have? AC? What's AC? No, is what? Is it the hypotenuse? Is it the opposite? Is it the opposite? No. No, it's not the opposite. Is it the hypotenuse? No. So therefore it must be the? Always do that. What do we want to find? AB. Is AB? AB is the hypotenuse? AB is the hypotenuse? It is the opposite. Therefore, being that we have those, we're going to say that since we don't have hypotenuse, then we can't use cos and we can't use sine. So since tan angle equal up over adj, tan 42 equals to, what's the opposite again? X. Yeah, so now I look for fine, we think them now, you know. X over adj. This implies that x over 40 is equal to tan 42. X over 40 is equal, what's tan 42? So x equal 0.9 times 40, x equal 36. 0.9 times 40. How many knows are 36? Eh? 0.9 is 9 over 10. 9 over 10 times 40 means 10 into 40 goes 4 times 9. 4 9s 36. See that? $100. All right, watch me now. What do you want to find? Do we have the hypotenuse? This is the hypotenuse. That means what we have to use? We have to use tan. So which one is the opposite? AB equals 36. AB equal, show me how to write madness. AB equal opposite, because it's this me I try to find. BC equal edge. Since tan angle equal over edge, it implies that tan x equal 36 over 40, tan x 36 over 40. All right, so when you have tan x and you want to get it now, you write tan inverse. So therefore, x equal tan inverse 0.9, x equal, some people get 41.9 something something. 42 what? Orange? 42 degrees in the shade. Him alone get money. Him alone first person get it right. Eh? When what? No. Because I have tan here, so I need to find the angle. To find the angle from tan, you do tan inverse. Tan inverse is the opposite of tan. You see it? So through more on the x alone, I have tan x. So if we get rid of tan, I have to do tan inverse. And then do it over here, so tan inverse. You see it? Prove that sine 60 equals square root 3 over 2, tan 60 equals square root 3 over 1, cos 60 equal 1 over 2, sine 60 who are looking at book? No, serious, no book. I don't know. The first thing I'm going to do is to find which triangle have equal sides. Which triangle have equal sides? Triangle. Here are. Isosceles have two equal sides. An equilateral all sides are equal. See that? So that is my equilateral triangle. If all sides are equal, then all angles are equal because it is the angle that makes the side. You know see that? So therefore, if all sides are equal, then all angles are equal. So it means that in an equilateral triangle, all angles are 60. You see that? Everybody see that? If you divide an equilateral triangle in two, you get 290 right angle triangle. Chook, 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 chook. You see that? To do that, therefore, you divide this angle in half, giving you 30 and 30 equals 60. No, no worry yourself about that. So over here, so is 30, 60, 90. And over here, so is 30, 60, 90. I'm going to give a number to a side. The number that they asked me for is 2. 2, 2, 2. So therefore, sine 60, in order for 1 to be 2, what is sine? Sine angle equal to opposite over hypotenuse. Therefore, if it is that sine angle equal to square root 3 over 2, it implies that the hypotenuse is equal to 2. Not true? You know, see that? Sine angle is equal to opposite over hypotenuse. Over here, so it said that sine 60 equal to this over 2. You see it? Now, if I take this is a 90 degree, you see that? That being a 90 degree, it means that sine 60, right? The hypotenuse have to be 2 because the bottom number 2, which is the hypotenuse.
So the top number opposite?
Yes, have to be the opposite. You see that? You see that string bean? So that means that the hypotenuse equal 2, which means that equal 2. You see that? Don't worry yourself, you soon reach there, sir. If this equal to, what kind of triangle is the big triangle? What kind of triangle is the big triangle? An equilateral triangle. So if this equal to, then all sides not equal. That means that this equal to, and that means that this equal to. You see that? However, this line was divided in 2. So this line equal 1 plus 1. You see that so far? You see that? Camouflage. You see that? You see logic so far? Good. Now, it tells us that over here, sir, hypotenuse HYP square equal to opposite square plus ADJ square. Remember that? Not true. So that means where hypotenuse equal to and opposite or adjacent equal 1. Any one of them, it don't matter. Because the way in which you add numbers don't affect the result. You see that? Where I equal 2, I'm going to say, and opposite equal 1. This implies that 2 square equal to 1 square plus x square. 4 equal 1 plus x square. X square plus 1 equal 4. X square equal 4 minus 1. X square equal 3. That means that x equal to square root 3. You see that? So that means that if this is the opposite 1 and this is the hypotenuse 2, then the adjacent is square root 3. All right, clear off everything out on the brain. Everything clear out on the brain. Everything clear. No, that didn't work. All right, watch me now. May I show the logics? You have some triangles, don't you? First of all, sine, tan, all them they go for triangle. Now that we learn. So we are going to use a triangle, don't you, to prove it. Because a triangle we are dealing with. You see? Yes. Good. What is the easiest triangle to deal with? The one we have all equal sides. Because from one side, all sides. Easiest triangle I have to deal with. So I'm going to jump in on my equilateral triangle. Copies? So I'm draw my triangle. That's an equilateral triangle. See? Yo, all eyes, just focus and use up the logics. A, B, C. See that? Yes. Now, what I knew from when I teach is that it's a 90-degree angle give me most of these things. Now, so you go. Does the equilateral triangle have a 90-degree angle? As is? No. But if I divide it in 2, I can get 2 right angle triangle from an equilateral triangle. So I'm going to now divide it in 2. Can see it? That is going to be line D. See that? Everybody see that? Wanna with me so far? All right. Now, they asked me to prove something in an equilateral triangle. All the angles are equal. Am I correct? The total angles in a triangle equal 180. There are 3 angles, and so if all of them are equal, it's equal to 180 divided by 3. Equals 60. So every angle, string B, is 60. This is 60, though. But I divide it in 2. So it must be, I divide it in half. You see that? So now understand to yes or no? Yes, now what you realize here? 60, 60, 60, 30, 30, 30. You see that? So I have all of my angles here. And this here are 90s. You see it? Oh, you know 90. Because the angle on a straight line is what? Is 180. You divide the straight line into 2, so you get 180 divided by 2. 90 and 90. You see that? Clock 90. Ready now? Sine 60 equals square root 3 over 2. What do I know? I know that sine angle equal to opposite over hypotenuse. Don't I know that? So if it is equal, if that is equal to this 3 over 2, it means that opposite equal to square root 3 and hypotenuse equal to 2. Now say go. Therefore, based on the fact that my hypotenuse is the opposite of the 90-degree angle, then I know that my hypotenuse for this triangle here is 2. You see that? Because it's an equilateral triangle, if this is 2, then this is 2, and this is 2, but I divide it into half, so this is 1 plus 1. You see that? What else do I know? I know that my hypotenuse squared is equal to my opposite squared plus my adjacent squared. I don't need to bother my mind which one is opposite and adjacent in this, because the way in which you add numbers don't affect the result. So if these are opposite and these are adjacent, it's not different from if these are adjacent and these are opposite. It don't make a difference. You see? But we're going to use this one, you know. Triangle ABD. You see that? In triangle ABD, what is my hypotenuse? AB equal to. What is my opposite? You can either use AD or DB. Anyone. Which one you want to use? 1 square. What's my adjacent? X. You see that? If me use that as my opposite, it would have simply be x plus 1 square. This says the same thing? So it no matter. So therefore, 4 is equal to 1 plus x. You see it? So that means that x plus 1 equal 4, you see it? 1 plus x is the same as x plus 1. So I carry my x over this side. That means that x equal to 4, oh, squared, sorry. Oh, yes, sorry. This is x squared. X squared, adjacent squared. X squared. So that means that x squared is equal to 4 minus 1. X squared equal to 3. That means that x is equal to square root 3. You see that? Everybody see that? Yes, sir. So that means if this is my opposite 1, this is my hypotenuse 2, that means that this here is square root 3. You see that? Good. Now, I don't have to work it out, because it never work it out. So them say then, sine 60. We will use triangle ABD. If this is a sine, which one is the opposite? If we have a sine 60, this is the angle, where is the opposite? AD. And adjacent and hypotenuse. Huh? A what? Sine 60 equal to opposite AD equals square root 3 and AB equal 2. So it equal to square root 3 over 2. See that? Sine. Sine angle equal opposite over hypotenuse. In this case, sine 60 is equal to, sorry, before we go there, sir. AB equal to hypotenuse equal to 2. Where's the opposite for 60? AD equal to opposite equal to square root 3. It implies, therefore, that sine 60 equals to opposite square root 3 over hypotenuse 2. See that? Now let's look at another one. Tan 60. Tan. Holy. It's about 15. It can, yeah. About 15 this. You know, it's an easy thing this. Tan 60. Tan equal to what? Opposite over adjacent. Which one is opposite based on the 60? Which is square root 3. Which one is adjacent based on the 60? So tan 60 equals square root 3 over 1. You see that? Cos 60. Cos 60 equal what? Opposite over hypotenuse. Adjacent over hypotenuse. So therefore, what is the hypotenuse? What's the adjacent? So 1 over 2. You see? So suppose we say prove that cos 60 equal 0.5. Do the same thing. 1 over 2 is a half. Go in a calculator and put cos 60. .5. Cos 60 0.5. So you see? If me on a calculator, I could have worked out cos 60. So it's simple. You see it? What is cos? Cos is opposite over adjacent. Adjacent over hypotenuse. Where is my adjacent? DB. Where is my hypotenuse? AB. So DB over AB is equal to 1 over 2. See that? Now you have a thing that they call complementary angles. Complementary angles add up to 90 degrees. So, if two angles are complementary, it means that when you add the two of them, it equals to 90 degrees. If you have a 90 degree triangle, a right angle triangle, it automatically means that the other two angles are complementary. You understand that? Because the total will be 180. This is 90. That means that this and this must add up to equal 90. See that? So they are automatically complementary. Now, when angles are complementary, it means that sine A equal to cos C. So sine of this angle is equal to cos of that angle. For example, if this is 60, what is this? This must then be 30. What is sine 60? All right, what is cos 30? So you see that? All right, what is sine 30? Sine 30. No. What is cos 60? So once they are complementary angles, which means that them add up to equal to 90, then the sine of one is equal to the cos of the other. Are you understanding? When two angles are complementary, which means that when you add the two of them together, it comes to 90. It means that the sine of angle A is equal to the cos of angle, the other angle. So sine 50 is equal to what? To cos 40. It have to add to equal 90. Sine 70 equal cos 20. It have to add up to equal 90. Sine 89 cos 1. Cos 40 sine 50. You understand? Good. All right. Now, when you square it, sine square angle is equal to sine angle all squared. You understand that? Mm-hmm. So sine square A equal to sine A all squared. See that? Sine square 60 is equal to sine 60 all squared equal to 0.5. Sine 60 at 0.5? 0.5 squared equal to 0.25. Yeah. Square that. 0.87 squared. Now I'm going to prove to you that sine square A plus cos square A equal 1. Yeah. This is A. That means that this is line A, line B, line C. Good? Sine square A is equal to sine A all squared. Not true? All right? Where sine A is equal to opposite over hypotenuse is equal to opposite over hypotenuse. Where is the opposite for A? And where is the hypotenuse? All squared, not true? So you go. Which equal to A squared over B squared. And I'm teaching you this morning. A1 times 2, B1 times 2. Cos squared A is equal to adjacent over hypotenuse. Where is the adjacent here? Adjacent is C. The hypotenuse is B. The opposite is A. So the other one must be the adjacent. C over A squared equals C squared over A squared. So this implies that sine square A plus cos square B is equal to A square B over B square plus C square over B square, right? Correct? Sorry. What's the hypotenuse? B. So this is C over B. C over B. What does it look like to you? A fraction. What is the LCM? B square. So B square into B square. 1 bracket A square. Plus B square into B square. Bracket C square. So therefore, A square plus C square over B square. Now, remember that hypotenuse square is equal to opposite square plus adjacent square. On that triangle, what is my hypotenuse? Yes, line AC, also called B. So B square is equal to, what's my opposite? A square plus what's my adjacent? C square. So if you look right here, so you see that A square plus C square is actually equal to B square. You see that? So this implies, say right here, so since A square plus C square equals to B square, it implies that A square plus C square over B square is equal to B square over B square. See that? See that? Which is equal to 1. Everybody understand that? You say it's simple? Because hypotenuse square equal opposite square plus adjacent square. So this is actually B square too. You see that? Yes, sir. See how it's simple?